Welcome to part 5 of my Understanding Lead-Acid Batteries. Today I'd like to explain what BCI group sizes are. When you look at most lead-acid batteries, there seems to always be some sort of random number like this 59 printed on it. Well, other than spiffing up the label and making it look nicer, does this number serve a purpose? The answer is, well, yes, it actually does. BCI stands for the Battery Council International. Batteries are used in every country in the world, and just about every country in the world also makes batteries. BCI was established so a battery made in one country will actually fit in a machine in another country. So if your battery dies, and its BCI group size is 59, every new battery that has a 59 code, no matter where it's made, will fit in your car. Your BCI group size will specify your battery physical dimensions, the exact length, width, and height of the outside of the battery, the voltage of that battery, usually 6 or 12 volts, and finally, your post configuration and location. Here are just a few of the defined terminal types, as well as some of their required locations. Let's take a look at an example. I have a BCI 27 battery. Its physical dimensions will always be 12 and 1/16 inches by 6 and 13/16 inches and 8 and 7/8 inches high. It will be a 12-volt battery. The terminal posts will be located on top outboard side of the battery, and post type will be A or A2. This is the type of terminal where you just slide the wire clamp down on it and tighten it up. What the BCI group size will not tell you is the battery capacity. I'll have more on that in just a sec. Also, it does not indicate the application of the battery. For example, a BCI 27 battery could be used for automotive, deep cycle, or marine. Remember, BCI simply tells you the physical dimensions and configuration. Now, back to the battery capacity issue. A battery that's built with recycled lead, for example from the cores of other batteries, will have less capacity than a battery built with virgin lead. This is lead that's never been in a battery before. And if you want to increase capacity even more, use a lead antimony alloy. The drawback here is you have more capacity but an increased self-discharge rate. And you will see a direct correlation between the cost of the battery and what type of lead they've used inside of it. So capacity is determined by what's inside the battery, and BCI describes what's on the outside of the battery. However, if we're talking about batteries within the same application group, such as deep cycle, larger and heavier batteries will have a greater capacity. So indirectly, BCI group sizes can be correlated to a capacity range. Let's look at some examples. Size U1, 34 to 40 amp hours. Group 24, 70 to 85 amp hours. Group 31, 95 to 125 amp hours. And 8D, we can get up to 255 amp hours. That's an awful lot of amps. Now, all these batteries are rated at 12 volts DC. And of course, I have to include the famous golf cart battery, 180 to 225 amps. You do need to keep in mind this is only a 6-volt battery. So to run it in a 12-volt system, you'll need 2 batteries in series. I'll cover that on my next video. Now, the nice thing about a chart like this, when you start shopping for a battery, it gives you a starting point. Let's say your application requires about 80 amps. Well, by looking at this chart, you know you need at least a group 24 or 27 battery. Batteries we just talked about were all deep cycle. So I've pretty much told you everything I know about BCI, but while researching BCI for starting batteries, I came across something that was a little confusing. So I'd like to take a few minutes to explain it, just in case anybody else was as confused as I was. I found a chart that said a Group 25 starting battery had 720 cold cranking amps, but it listed the battery capacity at 44 amp hours. 720 amps is a lot of amps. 44 is a really small number. How do you get 720 amps out of 44? Here's the problem. I'm trying to compare apples to oranges. Each of these numbers has a different time unit associated with them. So to properly compare these numbers, simply convert the time units to the same number. Let's use seconds. Remember from my previous videos, cold cranking amps is maximum current for 30 seconds. In this case, you're pulling 24 amps per second out of the battery, while 44 amps is a small current for 20 hours. In this case, 2.2 amps per hour. This translates to 0.0006 amps per second. So now we have the same unit of time. So your cold cranking amps is 24 amps per second, while your 44 amp hours is 0.6 milliamps per second. That's a big difference. Let's try looking at this another way. 720 amps is what percentage of the total capacity of that battery? Will batteries store electricity? Electricity is nothing more than electrons, so a battery is a big box full of electrons. How many electrons? The unit of measurement for electrons is called the coulomb. 1 coulomb is equal to 1.602 times 10 to the 19th power electrons. If you wrote the whole number out, this is what it'd look like. All these electrons are just sitting there doing nothing. Until they start moving, they're not really helping us. The way we get electrons to move is we apply a voltage to them. So the 6 volts on our golf cart battery will start these electrons moving. You want to move more electrons faster? Jump up to 12 volts. Once they're actually moving, we need a way to measure how many are moving. This is called the amp. 1 amp means you've moved 1 coulomb of electrons in 1 second. Let that 1 amp flow for 60 seconds. You have 60 coulombs. That's called an amp minute. And 1 amp flowing for an entire hour is called an amp hour. This is 3,600 coulombs. This number is derived from 1 second times 60 gives you minutes, times 60 again gives you an hour. Now that we know how many coulombs flow in 1 hour, we can finally figure out how many electrons are stored in this battery. Just multiply your 44 times 3,600, and we get over 158,000 coulombs. Well, remember, 720 amps is exactly the same as 720 coulombs. We can now pretty clearly see that cranking your engine for 30 seconds at 720 amps will barely even scratch the capacity of this battery. Well, that's about it. Thanks for watching.